Hello everyone, this is a video on incenters and circumcenters of triangles. Something quite complicated if you don't understand the first part of the chapter. They're quite connected to each other. Now, incenters is basically a combination of three lines, I would say, and finding a intersection point between them, okay? Now, if you try to bisect, dividing into two, the corner angles of a triangle, and you draw a line all the way, you will intersect at a certain point, and that's called the incenter. Now, this incenter can actually make a circle around it, having the incenter as the middle of the circle. Now, the circle has other phenomena like you can draw a perpendicular line to the middle. All three of them will be equal in length because they're all radius. Makes sense. So this is one phenomenon of incenters. How is this used? I don't know. Maybe architecture, engineers, and drawings. Now, circumcenters of triangles is basically the same procedure, but using the three perpendicular bisector that you learned before. So you're drawing three lines that bisects the line of the three sides of a triangle and make sure it's perpendicular. You will come with an intersection point called the circumcenter. Now, a circumcenter will produce a circle that is larger than the triangle, like outside the triangle. But this circumcenter or this circle will touch all three vertices of the triangle. Okay, so it's kind of like perfect, but not. It's like a perfect circle that touches all three vertices of the triangle. What else do we need to know? Oh yeah, so they're all radius. Alright, so that is some information that you have to learn, even though you're not gonna use it anymore. I never use this, but we gotta learn this. Too bad. This should be A. I'm just going to do an example for incenter and an example for circumcenter. I don't want to make this video too long. Question A. Find angle. Okay, I is the incenter of triangle ABC. So you need to know the difference between incenter and circumcenter. So incenter is the circle in the middle, right? I suck at circles. Okay, anyways, there's a circle in the middle. And the circle, if I remember, is you can have this, and this all perpendicular. Not sure if you're gonna need it. And they're all equal in length, right? Find angle, angle ABC. ABC, where's that ABC here? Oh, okay, so when we are producing incenter, do you remember what procedure we use? The procedure we use is we draw lines that bisects the angle on the three corners, right? So by making this incenter, suppose this is being bisected. So this is 50 degrees as well. Angle ABC is 50 degrees. Is there a reference? No reference. Angle BAC, same procedure, 19 degrees. Oh no, ABC is the whole thing, so times 2, 100 degrees. 19 degrees times 2, 38 degrees. Next question. B, ACB. Oh, just do angles on a triangle. So angle ACB, 180 minus 100 minus 38. Angle sum of triangle. No, I have no calculator. 80 minus 38, 42 degrees. Next question, number 2. In the figure, P and Q are midpoints of AC and BC, respectively. O is the circumcenter, so circumcenter will produce a circle. An ugly-looking circle outside the triangle. blah blah blah. If POQ is 110, find angle ACB. Find this one. Okay, let's see what we can use here. Now, so if O is the circumcenter, the way we produce circumcenter is perpendicular bisector, right? We gotta make sure that these are equal and perpendicular as well. So actually, we have two additional information there because the two lines used to make the circumcenter is perpendicular. OPC is equals to angle POQ equals 90 degrees. So by using angles on a polygon, like 4 angles in the shape, we have angle ACB equals to 360 degrees. 360 degrees is the total angle in a 4-sided shape. How do we know it's 360? The formula n minus 2, which is 4 sides minus 2 times 180 degrees is 360. Minus, so angle sum of polygon, minus all the other angles. So 90, 90, 110. So we have 360 minus 180 minus 110, 70. Angle 70. That is it for this video, and goodbye.